we will be discussing the problem in Pytle's book at page 207, number 4.100. Compute the magnitudes of all forces acting on member CDE of the frame. First, let us identify the given in which, in this problem, we are given the 80 kips force, where it is equivalent to 80,000 pound force, and we are required to solve for all the forces at the member CDE. Then, let us establish a free body diagram, like so. As we can see, if we are to use a moment at point A or E, we can already solve for a force that is directed in the y-axis. Let us then solve for these forces, for we will be needing these forces in solving the problem. First, let us establish a moment at E, since F sub x, F sub y, and F sub ax intersects point E, at their line of action. So we will not be evaluating those forces. If we are to use point E as a moment center, we will be evaluating two forces, in which the 80 kips force and force F sub y. Next, if we are to use point E as a moment center, we will be able to solve for F sub ay. Since we can already see that the other unknown forces have their line of action at point A, solving for the two-moment equation, we will be able to solve for F sub ay and F sub y. F sub ay is equal to 180 kips, and F sub y is equal to negative 180 kips. The negative values indicate the wrong direction. We can make it positive by changing the direction of the force. Now that we are able to solve all the forces we can solve in the system, since the other equations are dependent on one another, we should divide the members of the system into different parts. We either remove member CDE or member BA. If we are to use member BA, the only problem is that we would be using more equations to solve for the force at point E, and if we are to use the member CDE, we would be establishing less equations. Since we like to solve this problem in the easiest way possible, we are to use the free body diagram of member CDA. Now, let us analyze this free body diagram of the member CDE. As we can see, we cannot begin by getting the moment at point C or D, since we don't know the value of F sub x yet, and there will be no variable that has no unknown, for it lies within the line of action of force F sub y, thus rendering the only known variable in this system. But we can start with a force equation at y, since it is the only equation that has a known value. But we cannot solve this equation alone, for there are two unknowns, so we must establish another equation. Since we already know that we can use point C or D as a moment center, and the force equation with respect with x, for it has an unknown f sub x. We can try to use point E as a moment center. In order to find the relationship of the two forces that we are to find, solving the two equations that we were able to establish simultaneously, we'll be able to get this values. The negative value in F sub CD indicates wrong direction. Now that we were able to solve for the force present at members BC and PV, we now go to force E. Since we already know the y component of force E, let us now get the x component of force E. Since we're able to solve almost all of the unknown at member CDE, we can now use any equation which is present in the system to solve for the x component of force E. We can either use force or moment equation. To simplify the solution, let us use the force equation in order to solve for the x component of force E. Using the force equation in x, we can solve for F sub x, which is negative 80 kips. We can make it positive by changing its direction. Now, let us use the Pythagorean theorem to get the value of force E, which is 197 kips.